Xenon hexafluoride. Prediction of the hybridization shape, expected shape, and the distorted shape also we are going to discuss now. Xenon hexafluoride. Once again, I'll take you to the second excited state. Here only we'll finish it off. So in the previous structure of xenon tetrafluoride, we discussed the hybridization of xenon tetrafluoride. Now you know ground state, first excited state, and second excited state, right? So let me draw the second excited state once again. This will be second excited state. Now, once again, if you can promote this electron, you will get the third excited state. So, xenon, third excited state. So, you will have phi s once again undisturbed. In phi p, you will have 3 unpaired electrons, and phi d also you will have 3 unpaired electrons. So if you predict the hybridization, now we will couple with the fluorine. So this is first fluorine pairing up, second fluorine, one more pair, third fluorine, one more pair, fourth fluorine, one more pair, fifth fluorine, one more pair, sixth fluorine, one more pair. Therefore, here we have sp3d3 hybridization. So once you say sp3d3 hybridization, expected shape would be pentagonal bipyramidal, but is it pentagonal bipyramidal? No. Let us draw the shape of XeF6. First fluorine, second fluorine, third fluorine, fourth fluorine, fifth fluorine, sixth fluorine. One lone pair will be like this. Therefore, due to lone pair bond pair repulsion, it is called, the shape is called distorted octahedron, or we can also call it as monocapped. Why monocapped? One cap is available here because of the lone pair. Lone pair is forming as a cap, so it is called monocapped octahedron. And dipole moment of this molecule not equal to 0. So very, very important special case study of sp3d3 hybridization with one lone pair of xenon hexafluoride.